Kia ora Year 11 and Year 10s and Year 12s who are doing AS. This video is a request for Freeman, but I think there are heaps of you who would probably benefit from going over both trig functions and how to draw their graphs and graph transformations in general. So this is the third go I've had at making this video because I want to go through a couple of things really slowly, and I've decided it's probably going to take two parts. So if you're watching and you're finding it way too slow, please put it onto double speed. Make sure that you've got a pen and a ruler with you so that you can do the questions as I work. There are two main things that I want to highlight in here. The first is how we can draw our basic trig graphs and do some transformations. If you're in 13 MCA, you're going to find this part of the video very easy because we've done level 3 trig. The second part is where I want to look at how we can describe with the right terms graph transformations that get us from one function onto another function. And in the examiner report for November 2020, they noted that these two questions here were pretty badly done. So I think it's easy to kind of know how graph transformations work, but I want to go over the right terminology. That will probably be in the second half of this. Okay, so the first question requires us to do two things. We have to state the greatest and the least values of y, and y is this transformation of a trig function. So the next thing we have to do is to sketch that graph, and it's just for x between 0 and pi. So these basically go together, and in some ways it's easiest to get on with the graph sketching and then to read off the greatest and the least values of y. So let's think, I'm going to do these graphs badly and by hand because that's what you're going to be doing in the exam. Then I'm going to show you some nice graphs using GeoGebra. But what I am going to do is just rule up my x-axis. And I want you to notice the order in which I do things when I'm drawing the graphs, especially if you're in 12 MCA. So the basic cosine graph goes like this. And if I want to draw it, I draw it like that, and then I go back and I put my x and my y labels on. You must have your graphs labeled, and you also really need to label the key points. So the maximum here is at 1, and the 0 is at pi on 2, and this value here is at 2 pi. So the period of the cosine curve is 2 pi, that's one full cycle. So that's y equals cosine of x. Now what we're asked to draw here is y equals 3 cosine of 2x plus 2. So there are three transformations that have happened to this basic function. The first one, and in some ways the hardest one, is that the graph has been sped up. So cosine of 2x has a period of 2 pi divided by 2. That means that I get back to the start after pi units instead of 2 pi units. So let's quickly sketch that in now. So at this point down here, I should be down at -1, and my 0 point is going to be at pi on 4. So it looks like that. That's a pretty bad curve, but it's good enough. Right, so that's y equals cosine of 2x. The next thing that we're going to do is look at how we can stretch that to make y equals 3 cosine of 2x. So all that's changing here is that I am doing a stretch in the y direction, or what we can think of as a vertical stretch. Right, so we're stretching in the direction of the y-axis, and we're doing that by a scale factor of 3. And I'll go through all of this more slowly later in the video. But it means that my top and bottom numbers are going to be, instead of being 1, and I should have put a -1 on down here, it's going to go up to 3 and down to -3. So for this one, I'm actually going to hop to the nice GeoGebra sketch and show that to you, because it's going to go, this is going to basically go off my graphing scale here. So it's way down there. All right, so it's going to be a graph that goes like this. E. Okay, let's go to the nice GeoGebra one. Where are we? Have to find them. Okay, so I found the page with the GeoGebra on. So that's your basic cosine function. This one here is cosine of 2x. Right, so sped up, you can see there we've got one period of pi, and this next one here is 3 cosine of 2x. So the red function here is 3 cosine of 2x. Now the last thing I want to do here is I want to shift my graph up by 2 units, and that means that instead of having my midline on the x-axis, it's going to be up here at 2. And that means that the top of the graph will go up to 5 and the bottom will go down to -1. So when we graph that, it's going to end up looking like this one here. So the orange one in here is the graph that we want to be drawing. So let's go back to Freeman's request page. No, that's Freeman's other request page. Hang on, where's it gone? Here. Okay, so I'm going to draw this now by hand to show you how you'll do that in the exam. And the greatest and least values of y are going to be y is equal to -1 and y is equal to +5. So just get your axes in first, and then actually use your ruler to get the scale, right? The first thing we're going to draw in is the midline, which is at 2. Then we need to go 3 higher up to about here, and 3 below that down at -1, so about here. So we're going to start here, and we're going to go down to here. Right, so let's get rid of these little lines. We're going to mark some points on. So this is x, this is y is equal to 3 cosine of 2x plus 2. So this point is at 5, this point is at -1, and the midline in here is going to be at 2. And I'm just going to put a dotted line in for that. Okay, so that is probably not quite good enough. What else do I want to put on? I want to put on my special points on the x-axis. So I'm going to put on x is equal to pi here. I'm going to mark on pi on 2 here. And all of this is going to help me with the next part of the question. This is a pretty shocking cosine graph, but there we go. So the 0 point here is going to be at pi on 4. This is going to be at 3 pi on 4. Right. What's the next question? Now this is the bit where people started to find it really tricky, because I don't think everyone understood what was being asked. And it's really simple if you can interpret the question. So if we consider the straight line y is equal to kx, where k is a constant, we have to state the number of solutions for this equation here. So in the first case, we're looking at k is equal to -3. So what we're being asked to do is not to solve an equation, right? We're just being asked how many solutions are there between x and pi. Now, when I've got one function is equal to another function, finding a solution means finding the place where the two graphs meet. Right? For example, if I had this curve and then this curve, the places where I'm putting the dots are where there are solutions to one equation equaling the other. So by drawing a good graph of the left-hand side, which is this, I can draw this graph easily, and I'm just going to look for how many times the two curves meet. So we go over to our decent graph. The first graph that we have to draw is y is equal to -3x. And we can put some points in here and think about doing a table like we did back in year 9. We're going to start here, and we're going to find a second point. And what we want to do is we're trying to see if this negative sloping straight line is ever going to cut my curve. Now, the only way that would happen is if it cuts somewhere around there. So the point that I'm going to substitute in here, and there are different ways to do this, but this is my way, is I'm going to substitute in x is equal to pi on 2, right? And so y is equal to -3 pi on 2. Right? And you can see if you bung that into your calculator, you'll get -3 times 1.57 or so. So that's equal to, I don't know, -4 point blah, blah, blah. And that is far, far below where that graph is. So if you draw that graph on, let's get rid of that table, this is what it's going to look like. Right, and there are no intersections. So the number of intersections for those two will be 0. Okay, so that one is going to have no solutions. But you're not asked to say no solutions, you're asked to say the number of solutions, so it's 0. Now for the next one, we're going to do the same kind of thing. For k equals 1, how many times will it meet? So we go back over to our nice graph, and I'm going to do a little table. We know again that the graph is going to go through this point here. And here, out here at, well, let's use pi. if y is equal to x, then we're going to have the point x is equal to pi, y is equal to pi. And that means that this point about here is going to be on my graph. So we can take our ruler, we join it up. That's y is equal to x. Now it looks like that because my scale is not 1 to 1 on the two axes. You've got one solution here and you've got another solution here. So there are two solutions, right? Two solutions for that one. And then for the next one, k is equal to 3, we're going to do the same thing. If y is equal to 3x, then if we put in x is equal to 1, then y will equal 3. So we can find x is equal to 1, and it will be, let's think, it will be somewhere around here, and the y value is going to be here. And in this case, let's take off that line. We put on a new orange line, or maybe a new pink line. If we join that up, this is what we get. You can see that that straight line is shooting off quickly, so there's just going to be one solution. So this has been a really slow video to try and explain what I'm doing, but if you're actually doing this question and you have a good grip on how to put points into equations, I think it's a pretty fast question to do. Let's look at the last part now and see what's left. Okay, so this is a little bit different. This is not really related directly to the first part, except that we're starting with this function here, which is the one we already had. And then we've got two other functions. And we have to get a series of transformations or a sequence of transformations that take us from the first one to the second one. So how do we get from here to this one here? So for this, you need to understand the general idea of transformations of graphs. And it's easiest in some ways to go back not to working with trig functions, but to working with parabolas or straight lines. This is saying, take my function here, and instead of putting x into it, put 2x into it. So if we started out with f of x is equal to x squared, and we put in 2x, then what we get out of it is going to be 2x all squared, which is 4x squared. If we're thinking about what happens to my basic parabola, there are two ways to think about this. But I'm going to think about this one as a horizontal stretch. But the stretch factor is a fraction, right? So this is y is equal to 4x squared, and this one is y equal to x squared. So we've got f of x, and then we've got f of 2x. So we can talk about squeezing that, but the easiest terminology to use for the AS exams is to say that this is a stretch, and it's a stretch in the x-axis direction. And when you think about it like that, what's happening to every point here is that it's being pulled backwards, right? So this point here is being pulled backwards when we do the transformation. And so the scale factor is 1/2. Now let's go back and look at our cosine curve. What we're doing here is that we are putting in 2x instead of x. So the first transformation here is going to be that we've got a stretch, and it's the same wording, right? In the horizontal direction, and it's by a scale factor of 1/2. Now I'll do a second part of this video so that we can talk about this, and then we're going to also have to talk about this one here.